Do not scroll, as I'll be revealing 40 likely chemistry JAMB questions in this video. Let's get into it. Now, what is the number one question? Carbon atoms in ethane is dash. sp hybridized, sp2 hybridized, sp3 hybridized, sp3d2 hybridized. Now, this question is on hybridization, okay? Now, what do you mean by hybridization? It's just the mixing of two different orbitals, right? To get a maximum one, to get an orbitals of higher magnitude, in quotes. Now, so when we talk about hybridization, and here we are talking about ethane. Ethane. Don't forget, ethane is an homologous series, right? It's a member of what? Alkane. Is a member of what? Alkane. So when ethane, the hybridization of ethane here, which is alkane, is what? Is sp3 hybridized. There's alkene, which is what? sp2 hybridized. There's alkyne, which is what? Which is sp hybridized. So sp3 hybridized, sp2 hybridized, then sp hybridization. So for when we talk about, hydrocarbons, these are hydrocarbons, these are hydrocarbons, these are hydrocarbons. Okay. Why? They only contain carbon and hydrogen only. That's all. So now don't forget, another JAMB question here is that the general formula of alkane is what? Cn H2n plus 2. Alkene is Cn H2n. Alkyne is Cn H2n minus 2. You understand? That is the general formula of alkyne, this, alkene, this, then alkane, this. Another question that JAMB asked here is that what is the general formula of alloalkanes? Alloalkanes. Don't forget that allo here is halogens. That means it's a combination of alkane plus halogen. Look at it. That means you just take away one hydrogen from A and put X, which is an halogen. So this is what they do. Cn H2n plus 1. Then because it's an alloalkane, you now represent with X. Now this S representing halogens. Group 7 element, Abi? Group 7 element, halogens. And don't also forget that halogens, they are what? We call them salt formers. Halogens, we call them what? Salt formers. They form salts. So we call them salt formers, just like acid, sodium chloride, potassium chloride. Okay, salt formers. So please don't forget this. Where this X is an halogen, what are the halogens? It can be chlorine, it can be bromine, it can be iodine, then it can be what? Fluorine. So these are the X here. Okay. Question number 2. So the answer to this question, since it's an alkane, it is what? sp3 hybridized. Question number 2. The substance that serve as impurities during electrolysis of fused sodium chloride. Don't forget, when we talk about metals and its compound, one of the very important metal that you have to know is what? Is sodium, which is what? It has a silvery, appearance, and it's also soft. Don't forget, metals are meant to be hard, but sodium and potassium tends to deviate from that property. So they are soft. In fact, if you see sodium, you can cut it like this. Please take note of that. So now, during the electrolysis, since sodium is very, very reactive, right? It tends to be in combined state. You can't see sodium freely. It tends to be combined because of the reactivity. And because of that, sodium is stored under what? Tell me, it's stored under paraffin oil. Another JAMB question. Sodium is stored under paraffin oil. Sometimes they might put naphtha too. If they don't see naphtha, they can see put toluene. Sodium is stored under paraffin oil. Sodium is stored under paraffin oil. Take note of that because of its reactivity. Now, during electrolysis, you are supposed to reduce the what? The melting point. Don't forget, this sodium chloride is solid. It's solid. It's solid. The salt you eat at home. Now, it's solid, so you are supposed to reduce the melting point, right? So these impurities, don't forget, impurities tend to reduce melting point. Why impurities increase boiling point? Don't forget that. If it is for melting point, it will reduce. If it's a boiling point, it's what? It will increase. Don't forget. Now, because of impurities, now it's okay, yeah. The something that serve as okay, yeah. That means the answer to this question, sodium chloride, is what? Is calcium chloride. It will reduce it from 801 degrees Celsius to 600 degrees Celsius. That's what calcium chloride is going to do in this particular process. Okay. And don't forget, where does it take place? Tell me. It takes place what? In down cell. That is where it takes place. That's where it takes place. And I also want to tell you that you must know the anode and cathode of this process, of this electrolysis. The anode, do you know the way I know it? I said, oh, CAC, CACS. That means carbon, or sometimes they call it graphite, carbon anode. Then this cathode here, this cathode. Then what is the cathode? Steel. Steel. So that is what this is made up of. So you must take note of this down cell is made of anode, and the anode is what? Is carbon. Why the cathode is steel? Another JAMB question. Okay, so the answer to this question is what? C. Now, the next question here is on partial pressure. Yes, partial pressure. Partial pressure. Okay, now what you want to take note is that for partial pressure, look at it. What is the partial pressure of hydrogen gas collected over water at 760 millimeters of mercury? If the saturated vapor pressure of water is 25 millimeters of mercury at 25 degrees Celsius, this is one of the easiest questions you want to take note. Now, don't forget there's something called P total, which is going to be the pressure of the gas plus the partial pressure of what? Of water. Okay? Now, because you collect something over water, that means the total thing that you are going to be getting is the pressure of the gas plus the pressure of that water. So what you are collecting, what you are taking out is actually the water, pressure of the water plus the pressure of the gas. So that is why they will not ask you, what is the what? What is the partial pressure of the hydrogen alone? Collected over water at, because this one, that means this 760 is the total pressure. They will always give you the saturated vapor pressure, right? Look at it. The saturated vapor pressure of water should be this. That means, you know, I'm looking for the gas. Then the water is already set to be what? 25. So from here, I can say the partial pressure of the gas, in this case, which is hydrogen gas, is what? 760 minus 25. So this is what? 735 millimeter of what? Mercury. So the answer is option A. Never forget this. In fact, let me tell you, there's a question that they can ask you that calculate it at STP. But before that, let me give you a question. Let's assume that the partial pressure here, what is here is 800, and the saturated vapor pressure of water is 25. What will be the partial pressure of the, let me change this to oxygen gas. Oxygen gas. Oh yeah, drop in the comment section to know that you got it. What will be the partial pressure of oxygen gas? If it is collected over water at this, then saturated vapor pressure of water is this. Drop your answer in the comment section. Okay, so I will see those that got it. Number 4. Which of the following formulas is correct? People don't know this. People don't know when they say correct formulas. Okay. Now, when they say correct formula, don't be perturbed. You just need the concept of oxidation number. When they ask you correct formulas, what you need is the concept of what? Oxidation number. Once you know the oxidation number of this compound, you will know if it is correct or not. Because the first rule of oxidation number is that oxidation number of what? Of all compound. All compounds. So far you are a compound, this oxidation number of a compound must be 0. So now, let's go. Let's just test. What's the oxidation number of this guy? Is it 0? That's what we need. Number 1. Na2Al F6. Now, this is in group 1. So this becomes 2 into plus 1. This is group 3. this will come plus 3, plus, now this is minus. Fluorine, I told you, the oxidation state of fluorine must always be minus 1, except in free state, that it will be 0. But in any compound you found fluorine, it must always be minus 1, always, except in combined state. Why? Fluorine is the most electronegative element, hence it wants to maintain that reactivity and stand. So every other element must bow for fluorine. Okay, so that's why this becomes 6 into minus 1. So this becomes plus 2 plus 3 minus 6. This, when you sum this together, this is equal to minus 1. That means this compound is wrong. Let's go with the number 2. Na3Al F6. Let's go. This 3 we times to 3 plus 1 plus aluminum is plus 3, then 6 into minus 1. Then this becomes plus 3 minus 6. Oh yeah, does it? Plus 3 plus 3 plus 6 minus 6, 0. That means this is the answer. I don't know what is there. This is the answer. This is correct. Okay. Okay, now I will give you another question. Tell me if it is correct. There's a garlic. Let's say we have this Na3GaOH into 6, where the oxidation state of this one is plus 3. Okay, yeah, let me give you something like this. Is this compound correct? Just tell me if it is correct or not. If you have something like this, tell me if it is correct or not. Drop it in the comment section. So now, the symbol of beta particle, don't forget, when we talk about radiations, we have the alpha, right, particle, the beta particle, and the gamma ray. They are the 3 major radiations. The other radiations, we call them major radiations and minor radiations. So the major radiations are the what? The alpha particle, which is represented as helium nuclei, just like this, 4-2. The gamma ray, which is represented as this. Then the beta particle, which is present at the axis here. So please note, the beta particle is represented with electron, which is this. So sometimes they say B0 minus 1. So that is beta particle representation. So this is alpha, this is, gamma. The other radiations, like neutrons, positrons, all of those things, negatrons. So now if you have something like this is positron because it is plus 1 instead of minus 1. So this is one is electron, it's beta particle. Why this one is positron? Because it's positive. Okay, right, take note of that. If it is neutron, it will be what? 1, 0, N. If it is neutron, okay? Take note of that. Now, an element Y has 18 neutrons and 17 electrons. Its atomic number is dash. Its atomic number is dash. Very easy. Now, anytime you have question like this, you must take note of something, that if you have an element Y, you must know that this place can be related with A and this can be related with Z. Now, this A you are seeing means the mass number, which is equal to the number of proton plus number of neutron. Why Z you are seeing here, it's which is the atomic number, which is equal to the number of proton. Sometimes it can also be equal to the number of electron in a neutral atom. In a neutral atom, it will be this. In a neutral atom, it will be this. Except the atom undergoes some form of either loss of electron or gain of electron. But without that, it will be this. So in that case now, since we already know that the number of proton is equal to the number of electron in a neutral atom, so what is the atomic number of this guy? The answer is what? 17. So if I ask you what is the mass number, it is what? Number of neutrons plus number of protons. Now I told that this number of protons can also be equivalent to number of electrons. So in that case, what will be the answer here? If I ask you what is the mass number, it will be this plus this, which is going to be 35. That's why I put 35 here. Like, that's why they can put 35 and trick you. So that is that. So please take note of that. So if let's say if this, so the answer to this is this. But let me give you another question. Let's say this is 82, right? And this is, let's say, 127. We have dropped the mass number. What is the mass number of this particular element? What is the mass number? Drop it in the comment section. Now, this is under metals and its compound. Flame test. The flame color of sodium is dash. Now, sodium burns with a what? A golden yellow. Sodium burns with a golden yellow. This is what happened. You just find a compound that has sodium, right? Like sodium chloride. Then it is dipped with what? HCl. Another question, what is the compound used in flame test? HCl. Another JAMB question. HCl is what is used to concentrate any metallic compound. So that sodium chloride is dipped with this guy. Then you now find a stick. You dip it inside. Then you now see it with a flame, non-luminous flame, right? You now see a golden yellow. Then when you now look that golden yellow through a blue glass, nothing is seen. Then that is sodium. Oh my God. Let me teach you other ones like that. Now that is sodium. If it is calcium, calcium burns with a brick red coloration with flame test. But when you now see it through a blue glass, you see a green color. That is calcium. Let me give you another one. So that is calcium, Abi. Calcium is brick red with a flame. Then when you now view it through a blue glass, you see what? You see green. That shows that it is calcium. Now, potassium, when you do it with a flame test, you see what? Lilac. But when you now view it through a blue glass, what do you see? You see crimson appearance. That is what? Potassium. So don't forget that. That is potassium. The other colors, like lead is bluish green, copper is green. Those are the flame colors. Okay, you can take note of that. Reduction is the process of dash, or there are two questions there. Like it can be one option or two options. That's right, that is there. Don't forget that reduction, right? You must never forget this mnemonics. What is the mnemonics? Cryo. What is cryo? What cathode? At cathode, what happened? Reduction. At anode, what happens? Oxidation. That is one. The next thing you must know is what? Is LIOGA. LIOGA. What does LIOGA mean? Loss of electron is oxidation. Gain of electron is reduction. Okay, now let's answer that question. Reduction is the process of dash. Gain of electron. That means A is correct. Gain of electron. A is correct. Then I said, or that means reduction. Where does it occur? Reduction occurs at the what? At the cathode. Cryo. That means option C is correct. That's why the answer is what? D, B, and C. So don't beg and go and pick A and move on. There are two answers in this question. So the answer is what? A and what's it? Sorry. No, I think I made a mistake here. Sorry. The answer is what? So there's gain of electron, just like I can see. Then it occurs at the what? At the cathode. So the answer to this kind of question is what? A and C. A and C. Do you understand? A and C. That's the answer to this question. A and C. Because gain of electron is reduction. Then it occurs at the cathode. It's also reduction. So that is the answer. Number 9. Methane is an homologous series of dash. You must know this one. Look at it. Don't even cram. Methane. A. Which one has end with A? Which one ends with A? A. It's easy. I used to explain this thing very well to my students. Do you know what I tell them? Anyway, we started our marathon class. Okay, 7 days intensive class where we finish all your syllabus in 1 week. Physics, chemistry, biology, math, and English, everything is starting April 17th to April 23rd. So if you have not read anything, you have been working, or you just want to join us, you send me a DM. Either you are listening to this on TikTok or YouTube, you see my number around this part or anywhere here. Just send me a DM or WhatsApp to join us. We are going to start, today I'm recording this, it's going to start tomorrow. So if you want to join, send me a DM, okay? That will be the best thing you would do for yourself. Now, look at what happened. If you are Damilare, right, and you belong to the Ojo family, don't forget, Damilare is a member, is an homologous series of Ojo family. Damilare has a brother that bears Tunde. So what will you say? Tunde Ojo. What will you call me? My first name before my last name. Damilare Ojo. Damilare has a sister that bears Tope. It will be what? Tope Ojo. That is the way it is. Now, methane means the carbon is 1. Ane means they belongs to the alkane family. So what will you name them? Met. This is the Damilare. Met. It's just showing that this one is firstborn because the carbon is 1. Met is the Damilare. The A is the Ojo. So it's called methane. That's the way they name it. It's very easy. So homologous series are what? They are members of what? Of an organic compound which have similar method of preparation and same physical state. Okay, let's get to question number 10. Question 10. Now look at this. Ethane is stored in dash due to its reactivity. Don't forget that ethane is the first member of alkyne that have what? A general formula of Cn H2n minus 2. Abi, you already said that means there's nothing like n equals to 1. N starts from 2 for alkyne and alkene. So if n is 2, it will be what? C2 H2 into 2 minus 2. So from here you see C2 H4 minus 2, which is what? C2 H2. Okay. Now from here you can see that it has 2C, 1 hydrogen, 1 hydrogen. Okay, so this is what they mean by what? Ethane. Why do I have to go far from this? I want to show you something. This guy has what we call terminal hydrogens. Terminal hydrogen. Now, what is a terminal hydrogen? A terminal hydrogen is an hydrogen that is attached to the carbon that carries the triple bond. This one is very, very important because this is what makes alkyne undergo substitution reaction. If you don't have a terminal hydrogen, you cannot undergo substitution reaction as an alkyne. Don't forget that the major reaction of alkane is substitution reaction. Okay, so they love to substitute alkane because they are already saturated. Do you understand? But here, these guys who want to copy them, they want to do like alkane, so they can undergo substitution. Look at the one that will not undergo substitution reaction. Look at this. Look at this. Can you see? This one we have this, right? Then this one we have this. There's no terminal. Where is the terminal hydrogen? Nothing. Because hydrogen that must be bonded to a carbon that has this triple bond. So this has a terminal hydrogen. Hence, this guy can undergo substitution. I just want to teach you that so that you will learn something. So, but the answer to this question is that because ethane, in fact, is the most reactive. Like the alkyne, they are more reactive than alkene. They are more reactive than alkane. You understand? In that order. So it's stored under what we call propanol. Propanol. Take note of that. It's a JAMB question. Okay. Now, the ability of an acid to remove rust from a metal is called dash. The ability of an acid to remove rust from metal is called dash. Don't forget, I told you the other time that when you want to do what's it called? When you want to do flame test, you use HCl to do something. Don't forget. So this ability is called pickling. Pickling. And the acid we use majorly is also HCl. Okay, it's HCl. Take note of that. Industrial number 12. Industrial preparation of ammonia is called dash. You must know this one. It's called Haber process. Haber process, right? Haber process. Now, what must you know about Haber process? You must know that the reaction is very, very important. Now, is when nitrogen and hydrogen gas, there's a ratio. In ratio 1 to 3 to 2 to form 2NH3, right? Then this will be balanced. You put 3 here. So ratio 1 to 3 to 2. This process is called Haber process, okay? And this is ammonia. Don't also forget that quicklime is used to dry ammonia. Quicklime is used to dry ammonia. Don't also forget this. I think I've said this again and I'm repeating it. What is quicklime? Quicklime is CaO, calcium oxide. CaO. Okay, let's go. Ozone is allotropic to dash. Ozone is allotropic to dash. Ozone is allotropic to dash. Don't forget that this is ozone, right? And is also in gaseous state. But there's another guy that looks like ozone, which is what? It not look in the sense, but it has same state, right? So that means this is a gas, but different forms. So allotropy is a phenomenon where two elements, right, of the same physical state, but different forms. Two elements of the same physical state, gaseous, but what? Different forms. So you must never forget that. Same physical state, but different forms. So that is that. So this is ozone. So it's allotropic to what? Ozone is allotropic to what? Oxygen. And don't forget, what is the test for oxygen? Oxygen rekindles a glowing splinter. A glowing splinter. Don't forget this. And people don't understand this statement. Rekindles means you allow something to burn faster. That's why when you are burning something at home, that in the village, grandma will do something. When they are using a wooden something, they will try to fan it, right? Oxygen. So they are trying to rekindle a glowing splinter. So that's what it means. So that is by the way. Now, question 14. Chemical formula of gypsum salt is dash. Never forget, gypsum salt is calcium sulfate. This is gypsum salt. Calcium sulfate. Okay, that's that. So it's one of the ore of calcium, anyways. It's one of the ore of calcium. Now, limestone, marble, and chalk is represented with dash. Anywhere you see limestone, anywhere you see chalk, anywhere you see marble in chemistry, it means calcium carbonate, CaCO3. It means what? Calcium carbonate, CaCO3, CaCO3. That is not the normal name. That's what we call it. Okay, like just a way to know it. The actual name is what? Calcium triazo carbonate. What? I've taught you carbonate 4. You go and calculate the oxidation state of carbon. There's a video on oxidation number, oxidation state. I've uploaded a video on equilibrium, chemical equilibrium, oxidation number, redox, organic chemistry. A lot of videos. I've uploaded a lot of videos. So you want to check my YouTube. If you enjoyed to this point, I believe I've tried and it should help you, right? So subscribe to this YouTube channel. I'll be uploading 40 questions series. We are in the 40 question series. 40 questions in biology, 40 questions in physics, 40 questions in what is it called? In biology, physics, and chemistry. So these are the chemistry series. So biology will be coming soon. So that is that. Hematite is an ore of dash. In fact, it's not just an ore. It's the principal ore of this particular element. So you must not forget, it's the principal ore of this particular element. What is that element? Iron. So hematite is the principal ore of iron. And what is the formula? Fe2O3. That's hematite. Because there's another ore of iron, which is what? Magnetite. Which is what? Fe3O4. You understand? So the answer to this question, hematite is an ore of what? Iron. What are the another ore you should know is aluminium. Ore of aluminium. Aluminium. Which is what? Bauxite. Aluminium oxide. Al2O3. I've taught you another question like that too. Bauxite. So don't forget that. Cassiterite is an ore of dash. Never forget this one. It's an ore of tin. Tin. Sn. This one is Fe. Ferro. Cassiterite is an ore of tin. SnO2. Like tin, but the formula of cassiterite is SnO2. Okay. Now, industrial production of sulfur is called what? It's called Frach process. Industrial production of sulfur is called Frach process. Okay. Ether 1,2-dioic acid is dash. What they are asking about basicity. Please note, is dibasic. Is dibasic. What do I mean by dibasic? Look at it. This is the formula of ether 1,2-dioic. Let's say we have this here coming. So let's say we have that here. Ether 1,2-dioic. Look at it. is like this, COOH. COOH. Now, don't forget that it is this guy that is replaceable, right? So it can give 2H plus COO dash COO dash. So you can see that it has basicity of 2. Basicity of 2. And what? It is also what? Dibasic. Dibasic. Just like you can see. So the answer is dibasic. Liquid sodium is used as dash. Please note, is used as coolant. Is used as coolant. In what? In nuclear reactor. Liquid sodium is used as coolant in nuclear reactor. That's one of the things you want to know about sodium. Liquid sodium is used as coolant in nuclear reactor, okay? In nuclear reactor. If you enjoy it to this point, make sure you subscribe or you comment at below if this has helped you to this point. Make sure you comment, okay? And also, we've started our JAMB marathon. If you want to register, you send me a DM. I will display look at these are the what's called the topics. We broke them into different days, all your JAMB syllabus into different days. So if you want to register, send us a DM. My WhatsApp, I will display my WhatsApp number also here, so that you send us a DM and get started. Now, if G free energy is 0, the reaction is dash. You must never forget this. If the G free energy is 0, the reaction is dash. What does it show? The reaction is dash. Please note, if the G free energy is 0, it shows that the reaction is at what? Equilibrium. Equilibrium. Let me teach you other ones. If the G free energy is less than 0, which means if something is less than 0, that means that thing is negative. Right? It shows that the reaction is what? Is spontaneous. Spontaneous. And the G free energy is greater than 0, which shows this not equal. This is negative. Now, if it's greater than 0, that means we are positive. That means the reaction is what? Non-spontaneous. There's a reason for all of this anyways, but I'm not dwelling on that, but just take note of that. How many degenerate orbital is in p orbitals? Look at it. There's something called s orbital, which has only one degenerate, just one orbital like this. Now there is the second one, which we call p orbital. It has px, py, and pz. So for p orbitals, it has how many rooms? 1 room, 2 room, and 3 rooms. So these are what they call degenerate. They degenerate. So how many degenerate orbitals is in p orbitals? Is 3. There can be other ones, like d orbital. How many degenerate orbitals are we going to have in d? 1, 2, 3, 4. So it is 1, 2, 3, 4, 5. So for d, we have 5 rooms. Then the last one, there are other ones, but the common ones, the last, which is f, it will be 7. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7. So this is for f. It has 7 degenerate orbital. Now, don't forget that this one has 3, this one has 1. Don't forget that each room can occupy 2 electrons. So they can ask you, how many electrons can p orbital occupies? Is there from degenerate orbital? Like, is there from degenerate orbitals? So s can occupy, just like in your room, like in your house, there are different rooms. Now, each room can occupy 2 persons. So the persons are the electrons. So s orbital can occupy 2. Okay? This also can occupy 6, like 2, 2, 2. 1, 2, 3, 4, 5, 6. D orbital can occupy 1. Abi, it will go like this again. 10. Abi? So 10 electrons. This is 7 rooms. 2, 2, 2, 2, 2, 2, 2. That's 7 times 2. 14 electrons for f orbitals. This is very, very important. Okay? And don't forget what I did. Okay, the shape of s orbital is dash. Now, it's easy. When you see s, it's just so that it is what? It is spherical in shape. What is spherical? Just like this. Very easy. Now, the shape of p orbital is what? Is dumbbell. Is dumbbell. Just like the name. Dumbbell. What does dumbbell mean? You see something like this? Okay, so that's dumbbell. Okay, why the shape of d orbital is what? Is double dumbbell. Just like I can say double of this. What does it mean? So when you have something like this, and you have another one like this, okay, so this is what they mean by double dumbbell. Okay, and this is for d orbital. Why f orbital is complex? That's the shape, but it's not part of this question. Now, the degree of randomness of a system. Degree of randomness of a system. How disorganized a system is called entropy. Entropy. And is denoted with what? It's S. When we now talk about entropy change in S. Okay? So if you have enjoyed it up to this point, I hope you subscribe, right? If I've helped you up to this point, I hope you subscribe. I hope you enjoyed this. I hope you type comment in the comment section. I hope you share it with your friend. I hope just support in one form or the other. Okay. So now look at it, just like you now, for instance, you can see that your entropy is high because exam is near. So your degree of disorderliness is high because the exam is near. So if that's a job can ask you, when you move from water, which is liquid, to gas, what happened? The degree of disorderliness increased, entropy is increased. When you come from gas, that is, you see how your water is moving. When you take it back to liquid, the degree of disorderliness is calm. Entropy is reduced. So let your entropy be calm. I got you. Okay? I'll be uploading physics, chemistry, biology. These are series that I've dedicated for this period. So you want to subscribe so that you can get access to it. But anyways, we've also started our marathon class. Okay, it's going to start tomorrow. So you want to register, you see we've already compiled all the topics into 7 days. We'll be taking 8 hours per day, 2 hours each subject. If you have not read anything or you want to start afresh with your preparation, this is the best you want to do for yourself. So you want to send me a DM. You see my number around this description or on the screen. Then you want to send me a DM to get registered. So get started by the best, okay? Let me catch you. Now, coagulant in water is that. What is the coagulant? Let me explain something. There's something called the municipal distribution of water. That is water for township use. There are different sources of water, river, stream, lakes, and the likes, but they will not undergo some process to distribute into town. That's what they call this principal distribution of water. Okay. Now, what happened? There's actually a 4 main process, and the way I know it is can CD filter this. What does it mean? It means coagulation, sedimentation, filtration, and what? Disinfection. Now, you must never forget that that's why they use chlorine as what? As germicide to kill germs. Now, there are 3 halogens that are very important that they use. The first one is chlorine gas. Chlorine is used as what? As germicide. The second one that you want to know is iodine. Now, this iodine is used to prevent goiter. Especially the biology student, you must know this. It's used to prevent goiter. The last halogen is fluorine, which is used to what? To strengthen bone. To strengthen bone or teeth in this case. Now, that's why they will tell you to take, when you are brushing your teeth, they will tell you use fluorinated toothpaste because of this function of fluorine for strengthening of bones and teeth and all of that. So please take note of this. It is a common question that they ask, especially this one, germicide. As a germicide to kill germs. So you don't see germicide, you see kill germs. So this is what happened. So they coagulate, you sediment it through a filter, and you allow it to pass through. This one, it is the coarse, what's it called? Coarse solutes that use that particles. But here, there is something we call fine particle. That's when this one will pass through a filter bed. Then before you disinfect it, before you now store it, then you distribute. Do you understand? Storage, distribution. This is what is in your modern chemistry. But me, I just added, you after disinfection, what do you store? Then you distribute. Okay. Now, but the major question is that what do we use as a coagulant? Please never forget. What we use as coagulant is what we call what? Potash. Is what? Is potash alum. Potash alum. Potash alum. And I cannot forget. And because, do you know why? Because it's an example of a double salt. It's an example of a what? A double salt. So how do I know that it's a double salt? 2 cations plus 1 plus 3, then SO4, 2 minus. So 2 cations, 1 anion. 2 cations and 1 anion is a criteria to be a double salt. That's another JAMB question, okay? So the answer to this question is what? Is potash. Is potash alum. That's just the formula. Those are just extra things you need to know. So question 20. The component of duralumin are dash, dash, and dash. There are 4 main components of duralumin. Of course, you know that duralumin is an alloy, right? Mixture of metals. Now, I don't know why people miss this thing. They don't know that the word dura, yeah. Me, I think, oh, it is actually durable aluminium, right? That means aluminum that is durable. That's duralumin. I mean, aluminium, durable aluminium. Now, duralumin, one of the things that you want to know, first of all, the answer to this question is that it contains aluminium, copper, magnesium, and manganese. Those are the components, Abi. Now, duralumin has what, because it's durable, right, and it has low corrosive ability. You understand? That is one thing you have to know. That means it's better, right? Now, another thing that you have to know is that it has high strength, but what? But light-weighted. Is light-weighted. Is light-weighted, right? So, hence, it is used in aerospace construction, aircraft construction. Something having high tensile strength is high, but the weight is still light. So it can be used in aerospace constructions. Okay, that is what you have to understand. It's a JAMB question. Duralumin is used in aerospace construction or aircraft construction because dash the strength is high and light weighted. Take note of that. Okay, Alnico is an alloy made up of dash. This is a very good JAMB question, and you don't need to cram it. The component of the alloy is also the name. Aluminium, nickel, cobalt. That's all. Aluminium, nickel, cobalt. That's all. That's the name, that's the component. Okay, please take note of that. I hope you get that. So, catalysts affect the rate of reaction by dash. You must not miss this one because in my 3 times of writing JAMB, there was never a time that you know how to this particular question. So I know it to the core. Now, this is what happened. You know that when we talk about energy profile, the reactant we want to form the product, right? You should know now by now that this is what? Endothermic pathway. How? Because this one is shortened. That's not the reason. I can tell you why, actually. I can, when I trace it, right? And I want to change the H is what? HP minus HR. Let's assume this is 2 and this is what? 4. So eventually 4, this is product and this is what? Reactant. So 4 minus 2 will give me positive 2. So because the change in enthalpy is positive, then this is an endothermic reaction. Let's do for exothermic. Look at it. Now look at this arm. Look at this arm. So the way I used to know it is that when this one is exiting, exothermic, exiting, exothermic. So the same thing applies. This becomes HR and this becomes HP. So let's say this will be 2 and this will be 4. It will be increasing. This energy profile. So the same thing, changing H, which is what? HP is 2, HR is 4. So can you see this is minus 2, Abi? So eventually, because it is minus 2, you understand? Then we say this is what? exothermic, exiting, releasing of heat to the surrounding. Endo, absorption of heat from the surrounding. So this is endothermic. Okay. Well, we started our powerful marathon class. If you want to join us, where we'll be destroying all the topics, all the JAMB syllabus in your exam, you send us a DM. Okay. It's one of the best things you want to do for yourself. All right. Because we get tutored by the best people like Isaac Adenio is coming, Quiz Bend is coming, Copy Chemistry is coming, Nosbra will be coming too. So you want to be there. Now, we've not answered this question. Look at what happened. So if you have something like this, just like we said, there's something called activation energy. Abi? Now, the idea of this is that if you must have an energy equal to this or greater than this. Look at it. You want to fly. For you to be able to fly to the other side, that is for the reactant to be able to form the product, you must have an energy equal to that height or greater than it. Look at, I want to fly this place. If I want to fly, I must possess an energy equal to the energy here, or once it's greater, I can fly. That energy is called activation energy. That's why it is called the minimum amount of energy required for a reactant to form the product. Okay, that is what is happening here. So now the catalyst, so that means reactants want to form products. Catalyst coming now, we now make this thing to reduce. So that's why the catalysts affect the rate of reaction by lowering the activation energy. That's why in your JAMB pack, they will tell you that this is what? Uncatalyzed pathway. And this thing that you are seeing here is what? Is catalyzed pathway. Okay? It has lowered it. So this reactant can easily form the product. So it is by lowering the activation energy. It is by what? Lowering the activation energy. Lowering the activation energy. That's the answer. Aqua regi is a component of dash. Please note, it's 3 parts of HCl plus 1 part of HNO3. Right? That's aqua regi. Now, how do I know it? Because HNO3, some people call it regia, depending. HNO3 is 3, right? That means HCl is 1. So they will change. Look at it. This one is 1. So this one comes here. This 3 comes here. That's where I know it, So it is 3 parts of HCl to 1 part of HNO3. That's aqua regia. So you understand? There's aqua fortis, HNO3. Okay. Now, dash is responsible for the ring in brown ring experiment. Now, don't forget, for brown ring experiment, it is used for NO3 minus. But what is responsible for that ring nature is the presence of what? NO. Never forget this. NO. Because eventually, what you'll be forming is what? FeSO4.NO. So this NO here is what is responsible. That NO is called nitrogen 2 oxide. I mean, nitrogen 2 oxide. That's NO. It's NO that is responsible for that ring nature of the brown ring experiment. Okay? Take note of that. Question 33. Question 33. Now, this is a bit of organic chemistry. Reaction of alkanol plus alkanoic acid produces dash. Now, when you have an alkanol, that is ROH, reacting with RCOOH. So this is an alkanoic acid. This is their functional, this is their general formula. This is alkanol. Now, what happens is that the first thing you want to do is you want to form water. Right? If you want to form water, this is the way you form water. It is OH from the alkanol. We now combine with H plus from here. So this has already formed water. That is all. Now look at this guy. This guy is left. Eventually, this will form RCOO from this acid side. RCOO. Then R will now come here. So this thing is what we call ester as the old name. But the new name is what? Is alkanoate. Alkanoate. So is either you call it ester or alkanoate. So the answer to this is ester or alkanoate. Okay? Now, but there's a naming nature that is different. Now, don't forget, look at it. You see that I wrote the acid part first before I write the alkanol. But in the naming system, you call this guy first before you call this. Now, I can tell you categorically that this guy came from where? It came from, this is the acid part, this is the alkanol part. So this guy came from CH3, COOH, and CH3, CH2OH. That's where it comes from. I can tell you. But if you want to name this guy, this is a JAMB question. No? If you want to name, you call this side first before you come here. So what do you say? Now this is an ethyl because the carbon here is 2. So we say ethyl. Now, how many carbon is here? 1, 2. Ethyl ethanoate. Ethanoate. And don't forget that they have sweet smell. Okay? Ethyl, that's the name of this compound. Ethyl ethanoate. The oxidation number of Mn in KMnO4 is dash. Though I have a video on oxidation number, okay, you can watch it. It will help you a lot. Just check around this place. Hope you subscribe. If you have not, do so right now. Follow me. If you are watching this on TikTok or YouTube, just follow me, right? Subscribe, share it to your friends. At least I'll be doing JAMB series, 40 questions in physics, chemistry, and biology. You know, if you want to learn, follow now, okay? Now, KMnO4. KMnO4. The first rule is that oxidation number of a compound must be 0. Now, I must know that potassium is in group 1, hence +1. I need Mn, so I will represent it with X, right? Then this is what? 4 into what? Oxygen is what? -2. Everything equals to 0. So +1 plus X, 4 times -2 -8 equals to 0. +1 minus 8 is what? -7 equals to 0. S equals to what? +7. It is not 7, no. It is what? +7. It is not 7. Please note, this is oxidation number. 7 alone is valency. So the answer to this question is what? Where is it? Is +7. Now let's do the second one. They asked me this one in my exam. So I still remember this question that they asked me. I remember most of my questions till today. Now look at it. Same process. K2Cl2O7. Oxidation number of a compound is 0. Now this is group 1. So 2 into +1 plus this is 2 into X, then +7 into -2. Oxygen is -2. This is +1. I need this. So everything equals to 0. Okay? Now this is called +2 plus 2x minus 14 equals to 0. +2 minus 14 is what? -12. So 2x minus 12 equals to 0. Then 2s equals to +12. Then s equals to 12 divided by 2. Then s equals to what? +6. That is why the name is what? Look at this. You know we got +7. So there's a left, middle, right rule of naming. It's on my YouTube. How to name any inorganic compound. So look at it. Potassium, tetra, oxo, manganese what? Manganese 7. Now we already got the oxidation number of Cl here to be +6. Yeah, let's name it. We call the left first, then we call the right, then we call the middle. I call it the left, right, middle rule. So potassium, hepta 7, oxo, dichromate 6. Okay, now SO2 and H2S change the purple color of KMnO4 to dash. You must not forget this. The answer is what? You private chat me. Private chat. Private chat. What does private chat mean? So SO2 and H2S, they are both reducing agents. This one is an oxidizing agent, okay? But they will change this color from purple to what? To colorless. Purple to colorless. That is where private, purple, C, colorless. If it is not this one, if it is K2Cr2O7, K2Cr2O7, you understand? If it is K2Cr2O7, it will change from what? Orange to what? To green. It will change from what? Orange to green. So I will tell you that don't go, form OG, orange to green. So if it is, so SO2 and H2S will change orange color of K2Cr2O7 to green. So you form OG. But if it is KMNO4, it will change from purple to what? Colorless. So the answer to this okay, I've already said it, colorless. Why? SO2 can act as both dash and dash. It can act as both reducing agent and as oxidizing agent. This is a question from JAMB. This one, directly. These are JAMB questions, okay? The general formula of alkanol is dash. You must never forget this one. Alkanol is dash. Okay? Alkanol is dash. Now, alkanol, right, is Cn H2n plus 1 OH. Okay? If it is other ones, let's say, we know we have alkaline, RCHO. So it is what? Cn H2n plus 1 CHO. What is important that this R is called an alkyl group. An alkyl group itself has a general formula of Cn H2n plus 1. So that is why you always see that they always put this with the OH, this with this. Do you understand? So that is that. So the answer to this is Cn H2n plus 1 OH. Okay? The last question, primary alkanol undergo complete oxidation. You must never forget this. Complete oxidation to give dash. If it is complete, it will give alkanoic acid. Alkanoic acid. If it is primary, but if it is primary and it is partial oxidation, it will give alkana. So there are two stages. If it is partial, it will give alkana. Okay. Then if it is complete, it will first give alkana. Then if it is complete, it will give what? Alkanoic acid. That's primary alkanol. If it is not secondary alkanol, the product, the only product, not even the product, the only product that is going to give is what? If it is secondary alkanol, is going to give what we call alkanone. Alkanone. But tertiary alkanol gives no product. Gives no product. You must know this. So on oxidation of a tertiary alkanol, there will be no product. On oxidation of a secondary alkanol, if it is tertiary alkanol, no product. Secondary alkanol, alkanol, that's the only product. Primary alkanol, we first of all give alkana, then it will now later give what? Alkanoic acid. Okay? So, because they already said complete, so that's why the answer is alkanoic acid. I hope you learned a lot. Oh my God. You have to subscribe, okay? You have to subscribe or else. But yeah, subscribe to this channel. I hope you've been able to get a lot of concept very clearly, okay? I'll be doing this as much as possible. So far, you subscribe, you comment, you like this, so I will do it more. So it shows that you love it. You encourage me to do more. So if you also want to join the marathon class, you can send me a DM, okay, to join, where all the four subject combination will be detailed, explained by great tutors, myself and other people. Okay, so till we see again, peace. So you guys should support me. Okay, what do you want me to do next? Should I continue this, or you want me to